All right, so yesterday when we did our wall work, we talked about how direct variation is the same thing as proportional. We also talked about ways that we can figure out if something is direct variation or whether it's just linear. Now, I want to remind you that when we think about direct variation, we have like linear here, and direct variation is a type of linear function. So linear kind of like, so like I'm a deal. Which deal am I? I'm Maggie deal. There are other deals, but I'm Maggie deal. So linear is like the family. Proportional direct variation is a type of linear function. So if it's direct variation, it's also linear. Okay? So when we compare direct variation and linear, a lot of times, like, y'all start to think that direct variation and linear are completely different things. No, direct variation is a type of linear. Okay? So if something's direct variation, I know that it's linear. So let's talk about kind of a couple of things that we need for today. Yesterday we talked about how y over x is the same for all rows. Y over x is actually a value that we use in direct variation. It's the constant of variation. We also call it the constant, let me zoom in, the constant of proportionality is what y'all called it last year. Y'all called it the constant proportionality last year. And the letter that we use to represent it is K. Okay? So remember how over here we said y over x is the same for all rows? Well, K is y over x. So yesterday when you guys were calculating y over x to see which table was direct variation, you were already calculating K, you just didn't know it. All right, it's math in disguise, okay? So, once we know K, and we use K to decide if something is direct variation, once we know K, it's really easy to write the equation because it's literally y equals kx. So whatever K is, we just plug it in, and that tells us what our equation is. So direct variation is the easiest kind of linear stuff to deal with. So let's do an example. We're going to do an example of something that is direct variation and something that isn't. And how we would find K, and then we're going to write an equation. So when we talk about, so in algebra, in 8th grade math, which we're still, so we're kind of weaving 8th grade math and algebra kind of there, we're doing them kind of together, weave together. So in 8th grade, well, in 7th grade when y'all did proportionality, you were really kind of responsible for identifying whether it was proportional. In algebra, we're responsible for identifying whether it's proportional, finding K, writing an equation, and finding a missing value. So we're kind of like, it's like we took what y'all did before, and we're kind of amping it up. So we're taking it kind of to the next level. So we're going to learn, yesterday we learned how to tell if it's proportional. Today we're going to learn how to find K and write an equation. And then Monday we're going to work on finding missing values. So let's talk about finding an equation. Let's draw a line right down the middle here. We're going to have a non-example and an example. So over here we're going to look at something that's not direct variation. Okay? So on the left we're going to look at something that's not direct variation. So the table that we're going to use has x and y. That's crazy looking. Let's do that. I'm going to do that again because that looks nuts. X and y. Great. It's going to go on YouTube. Okay. And we have 4, 3, 5, and 4.5, 11, and 13.5. Okay? So, when we decide if something is direct variation, the first thing we do is we got to take y, especially if it's a table like this, we got to take y and divide it by x. So what I do to help me with that is I actually make a y over x column, and I calculate it for each row. I am fond of my calculator, so I let my calculator do the math for me. I don't have to do that math. I got a calculator. I'm not trying to make any mistakes. So I take y is 3. 3 divided by 4 is 0.75. Okay? And then this one, sorry, it's 4.5 divided by 5. So I put 4.5 divided by 5 in, and I get 0.9. So is this direct variation? No, I can already tell. And if I do the third one, 13.5 divided by 11, I get 1.23 approximately. So this is not direct variation because y over x isn't the same for all rows. Yes?
So basically just like a decimal?
It's not because it's decimal, it's because they're not the same. If they were all 0.75, it would be direct variation.
Oh.
But because they're all different, or even if two of them are different, if one of them is different, one of the things that they like to do to mess with you, when, like if on tests, when they're trying to get you to see what it is, they'll make the first 3 rows work, and then the last one doesn't. It's kind of a jerk move, right? But that's what they do. They do it with linear, too, and linear's rate of change is even more complicated. Okay, so that's why this one isn't direct variation, because y over x isn't the same for all rows. Okay? Questions about that? We okay with that? Okay, so now let's look at this example. So this one, yes, exclamation point. Direct variation. You don't have to put exclamation points. I'm just really excited about it. As you can tell from the tone of my voice. I'm just really excited. Just kidding. Okay, so let's look at this table for this one. This one is 9, 3, 15, 5, and 30, 10. So let's look more closely at this one. All right. So what do I have to do now? What should I do now? What? Yes, find y over x, which is unit rate. Okay? So we're going to make ourselves a y over x column and calculate it for all of these. So I'll do that, you do that, and then you check and see if I did it right. When you're ready, check and see if I did it right. Huh? Okay, so we agree with this. All right, so because all of these are the same, this one, yes, this is direct variation. Because y over x is the same for all rows. Okay? Now, what's kind of awesome about this is we basically killed 3 birds with 1 stone. Okay? The first bird we killed is we know it's direct variation. Okay? So that's thing number 1. Thing number 2, it's linear. Because direct variation is always linear. Okay? So we know it's direct variation, but because it's direct variation, we know it's linear. Also, we know that k is 0.33. So we're ready to write our equation because we've got everything we need. So we basically, when we figured out that this was direct variation, we got 3 important pieces of information. We know it's direct variation, we know it's linear, we know what k is. Okay? All right, so now that we know all this good stuff, when we know k, we're just one step away from writing an equation. So So I want to go through and I want to go over here to this writing an equation page, and I want to do that process one time on this example, okay? And we're going to write down a process for you. Now, do you have to use this process? Kind of, yeah. But, sometimes I know y'all like to have a process written down, so we're going to do that, okay? So let's use these numbers. So we have -4 and 1. -3 and 0.75, 2 and -0.5. All right? Now, if we want to write a process, step 1 would be make a table. We don't always get a table. Sometimes they'll give us a situation, like on tonight's homework. There's a situation about some guy working and getting paid $12.75, I think, an hour. Okay? In that case, we would make a table. We would build a table that we could use to find. Now, obviously, anyway, I know some of y'all know how to jump straight to the equation. All right? But again, we're practicing this process on the easy stuff so we can do it on anything. Okay, so step 1 is make a table. Step 2 is make a y over x column, that's column, to find k. Well, yeah, to find k. Well, really, we're not finding k. To decide if it's direct variation. So we're making that y over x column to decide if it's direct variation. So I want y'all to take a second and do that now. After you write that down, go ahead and find y over x. Now I want to remind you, this negative right here, you use that button for. If you use the other one, you're going to get an error that says error syntax. Okay, so make sure you use the right button. Everybody, once you're done writing that down, sorry about that mess right there, go ahead and take a minute and find y over it's division. When you're done, take a look and see that bar between the fraction top and bottom means divide. Okay, so when you're done, take a look and see if we got the same answer. If I got the same answer as you guys. Okay, is anyone still working?
Wait, how do you get the answer?
Huh?
Is this a U graph?
No, you do top divided by bottom.
Is it like to show the answer?
Oh, I don't know about that. We'll worry about that later. Okay? Let's focus on this. Okay? Okay, so what 3 things do we know right now? Huh? Okay, so we know K. We know that K is -0.25, which is great because find K is the next thing we're supposed to do. And what's K? It's y over x. Okay? Now again, I know you're like, but I found K, but they might ask me for K. So I'm going to make a point of writing down K equals -0.25 because that's important. What else do I know just by looking at this? Huh? It's linear. And why do I know it's linear? Because it's what? It's direct variation. So I know that this is direct variation. I also know this is linear. And I know K. Just from doing that step right there. And that was easy. Okay? Now is the easiest step, the last step. Well, for now. Substitute K into y equals kx. So I have y equals kx. Well, k is -0.25. So y equals -0.25x. And now I have my equation. Okay?